Hello and welcome to another mathematical studies video. I'm going to use the invNorm in different ways, and in this video we're probably going to deal with what might be the hardest possible question you might have with the normal distribution, and we will finish with the normal distribution syllabus. So we've saw that the invNorm gave us the smaller than values. Now what do I mean by that? I mean that, for example, we use the invNorm and we introduce the probability of 0.25 in my good old intelligence quotient distribution. So mean 100, standard deviation 20, and an area of 0.25. I introduce that and I get this value. And what this value actually means is that what the invNorm is telling us is that the probability of getting something from minus a very small value, like the smallest possible value, the person with the lowest intelligence quotient, up to 86.510200501, the probability of finding someone there is 0.25. That's what the invNorm tells us. It tells us the value such the probability of finding an element is smaller than the value that is given. Great. So what happens if we find something that it's bigger than? Well, this is what we do. So suppose we want to find a value such that any element, like the probability of finding an element bigger than that value is 0.25. How do I find it? Well, here's the situation. I want to find this value here. What is this thing here? Where am I here? So finding somebody who has an IQ over that, the probability is 0.25. How do I find that value? Well, simply this is what I'm going to do. I'm going to realize that the other side of the bell curve is 0.75. This is 0.75. Right? Because the whole thing, the whole area under the bell curve is 1. So if this is 0.25, this must be 0.75. Now, how is this helpful? I just go to my calculator, and this is what I'm going to do. If 0.75 is the probability of finding something smaller than the value I need, I just paste it in my calculator, find out the value, and there you go. That's my answer. 0.25 now is the probability of finding an element bigger than 113. Great. Now, they could make it a little bit even more complicated by asking me to use the invNorm in between values. Now, how might that happen? It could happen in several ways, but first, let's think about it and let's look at the following example. So, I want to find an interval such that finding a value within that interval between this value and this value is 0.25. Now, suppose they give us one value. They're going to give us the 80, right? They're going to give us the 80 as the lowest bound. And I want to know up to where? Up to where? Up to 100? Up to 90? Up to where is the probability 0.25? So this is how I'm going to do it. Well, I'm going to first calculate the probability of finding a value below 80. I type it into my calculator and I get 0.158, 65, etc. Now, if I add 0.25 to that, what am I going to get? Well, I'm going to get this area here. And actually, well, if I find out what this value is, which I can do with the invNorm again, if I find out what this value is, I'm going to have this value here. So 0.409, all I have to do is go to my invNorm again and use 0.409. I calculate that, and I'm going to get 95.4. So the probability of finding something between 80 and 95.4 is 0.25. And that's how we use the invNorm in different situations. Now, let's do an exercise to practice, and that's it for the normal distribution. Here's the question. There's 2,000 people taking an external examination graded out of 100 points. The mean score is 60.1, and the standard deviation is 23.7. So first question, pass mark is at 50. How many people passed? Well, I'm just going to calculate the probability that one person got more than 50. Then I take one person out of the 2,000 and they got more than 50. So how do I do it? I just use my normal CDF. I don't use the invNorm for this. I just calculate from 50 to 10 to the power of 99 of distribution with mean 60.1 and standard deviation 23.7, and I get 0.66500, etc. So if that's a probability of finding one person out of 2,000 people, I'm going to multiply and I get that 1,330 people passed the exam. Question 2. What was the highest score obtained by the worst 200 candidates? Well, in this case here, Well, I need to find the probability of finding the worst 200 people. So the probability of the worst 200 people is 0.1, right? If I have 200 people out of 2,000, the probability that if I mix them all up together and I pick up something random, that person belongs to the worst 200 people, the probability is 0.1. And now I go to my invNorm, and this is what I type in. Area 0.1, mean 60.1, standard deviation 23.7. And so I get 29.727, etc. So that is going to be the highest grade among the worst 200 students, 29.7. Great. And finally, of the students that passed, in what grade interval can we find the 100 students with the worst grade? So I look at the students that passed, of the 1330 students that passed, okay? And find out which, like those students, right? Which 100 students with the worst grade. And the lowest one might be at 50. So where is the student with then there's another student with slightly better grade and so forth. Of those 100 students, who has the best grade? How do I do that? How do I calculate that? Well, we know that 1,330 people passed and 670 failed. So what's going to happen? The worst 100 students of the one who passed, if I add them to the ones who failed, I have 770 students. So quite simply, 770 over 2,000 is going to give me 0.385. And so I just calculate my invNorm again, and I get 53.17071492. And that's going to be the grade between which they are. So the students who passed the worst 100 got a grade between 50 and 53.2. It's not very straightforward how to use normal distribution the first time around you see it, but as you do more and more exercises, you will get better at it. I encourage you to go there and practice the ideas that I've set forth. Good luck and thank you very much for watching. Goodbye.